Okay, we're going to use those same math techniques, just basic dimensional analysis that we do with stoichiometry to solve another stoichiometry problem that's a little more complicated. The reason why it's more complicated is it's not just giving you one thing and asking for another. There's multiple pieces here. We still need a balanced equation. We still need to have the information given to us, and we're going to go through the 4 boxes. However, let's see how many things we have. So this says that we have 10 grams of propane. Okay, so that's grams of propane. And then it says it reacts with 21 liters of oxygen. That's also the first box. So that's 2 A's. And then it's looking for the mass. Mass is grams of carbon dioxide. So carbon dioxide is going to be the B. And we're going to go from the first box to the second, that's one conversion, to the third using coefficients from the balance equation, and then to the fourth. But again, we have 2 A's. So we have 3 things in this problem with numbers or with a question. And when you do that, you can't do it all at once. So my analogy for this is if you're cooking and the recipe calls for 2 cans of this and 1 can of that, and you have this many cans of each, how much can you make? Well, you typically have one that you have plenty of, and at the end of it, you still have some, and then you have one that you use up. The one that we use up is going to be called the limiting reagent. The limiting reagent limits the production. It's what gets used up. The one that doesn't get used up, and again, these are reactants, is going to be called the excess reagent, or it's in excess. And when the reaction is done, you'll still have leftovers. So the question may come as, how much of the leftovers do you have? And then in the end, we also are typically calculating what is the maximum amount of product can we form. So we're looking for mass of carbon dioxide, and we're looking for how much, what is a maximum capacity? What is it, how much? And it doesn't mean we do make that much, because theoretical means in theory, like not necessarily in practice. So you should be able to make this much. It just doesn't mean that you do. All right, this is my little cryptic thing down here. So this is supposed to be going through the 4 boxes, starting with a reactant, some kind of reactant, and we're going to go through the 4 boxes. So we're going to have 3 conversions. And we're going to cancel, cancel, cancel like this, end up with this guy. That's what this is supposed to be, is 3 conversions. On the other hand, we don't necessarily do all 3 conversions. Sometimes we do, sometimes we don't. Now, this guy, R prime, means a reactant, or R double prime means a different reactant, as in this could be the propane and this could be the oxygen. But we will go to the same product. So P is a product with a prime, P is a product with a prime, same product, same units. So we're going to get a mass of carbon dioxide for both of them. So we're going to do 2 conversions, one from the grams of the propane given and go to the mass of the carbon dioxide. And the other one, you're going to go from the liters of oxygen and then also go to the mass of carbon dioxide. So we'll have 2 carbon dioxides on the bottom. Now right here, this says that the smallest product will be the theoretical yield. The other one will be a bunch of crap. So we're not going to be able to use that one. It's junk. Then it goes on to say the reactant that got you to the theoretical yield, it got you to the smallest product, that thing will be the limiting reagent. So let's do the math and see if we can't figure this out. I'm going to go from the 10 grams of the propane. I'm going to do 3 conversions to the mass of carbon dioxide. Mass of carbon dioxide. So if you add this up, you're going to have 36 and 8, that's 44. And then all the extra pieces is going to be 11. So you get grams, 1 mole. This is all of propane, C3H8, C3H8. Grams are canceled, now moles on top, moles on bottom, and it's moles of propane on top, so moles of propane on the bottom. Where did I get the 1 from? Do we automatically have it? No, it's the coefficient in front. It's the understood 1 in front of it. And then we're going to carbon dioxide. So put 3 moles of carbon dioxide over here. 1 mole, because this is a mole conversion of carbon dioxide, to grams. So that's going to be 16 and 32, and then another 12. So that's going to be 44.01. Cancel. The actual units will cancel. These units will cancel. These units will cancel, leaving you grams of CO2. And that's what we're looking for. So we just do the calculation, and I got 29.9 grams CO2. What does that mean? Well, if we use up all this propane, then this is the maximum amount we can make. But we don't know if we use all of it up. So we got to start all over again with the second one, which is going to be liters of oxygen. So I'm going to have the 21.5 liters of O2. And again, we're going to go through the 4 boxes. So we're going to have 22.7 liters, 1 mole of O2. And it cancels this way. So we're going to have 5 moles of O2 because coefficient. And we're going to carbon dioxide, so coefficient, 3 moles. The only time you put in coefficients is when you do a conversion from one compound or element to the other one. And then these top 2 and bottom 1 will be identical over here, as you will see. So we got 1 mole of CO2 and then 44.01 grams CO2. And let's see what we got. 25.0 grams of carbon dioxide. We went to the same compound, the same unit, so these are going to compare 1 to 1. And now we need to figure out which one it is. Well, we're going to pick the smallest product to be the theoretical yield. 25 or 29. 25 is our smallest one. This is going to be our theoretical yield. The yield is an amount of product. So you need to have the numbers with the unit and the product. And the other one is a bunch of crap. I say that because, not to be all cutesy, but people always want to use this number. But if it's a bunch of crap, we're never going to use that number. Then this next part says the reactant that got you the theoretical yield, which is going to be the oxygen in this case, is going to be the limiting reagent. So let's figure this out. If we use up all the oxygen, we can make 25 grams of carbon dioxide. And if we can use up all the propane, we can make more. But what happens at the point at which you make 25 grams of carbon dioxide? And at the point that you make that much, the oxygen will run out. Without oxygen, you don't have a chemical reaction. That's gone, the reaction stops. And therefore, it limits the production. So whenever you have this kind of problem, line up the 2 reactants, go from reactant to the product, the other reactant to the same product. Pick the smallest product, and that will be your theoretical yield. And the reactant that got you there will be the limiting reagent. Now we have a couple more things we can do with this. One of them is how much of the excess is left over. So we're assuming, because of the math, that the oxygen will run out and therefore there'll be none. But that means that of the 10 grams of the propane, some will be used up and there'll be some left. Well, whenever you do the calculations through the 4 boxes, we're saying, if you're looking at a reactant, we're saying if used, and look at a product, then formed. And if we go the other way around with it, if we're looking at a product first and say this much is formed, then we're saying this much is used for the reactant, not leftovers. So this is what we have of the excess reagent. We have 10 grams. We're going to use some of that, but not all of it. But the question is what's left over. So what you do is you have the have. How much do we start off with? They're going to tell you in the problem. We're going to subtract out the used. We're going to get the used going through the 4 boxes. And then you subtract those to be left over. if you're subtracting the two reactants and they're the same reactants, they also have to be the same unit. If they're not the same unit, it won't work. So this says we start with a limiting reagent, which is going to be our oxygen, and we're going to the ExR reagent, which means we're going to grams of propane. Let me get some room here and we'll do that. So we're going to go from the limiting reagent, which was the oxygen, and then we're going to go to propane, which is the ExR reagent. And since they give us liters of oxygen, we start with what they give us. They give us 21.5 liters of oxygen. And then we go through the boxes. We got 22.7 liters oxygen, 1 mole of oxygen. That's 1 mole. And then that's the mole conversion. Here is going to be going from using the coefficient. So we're using 5 and 1. So we have 5 moles of oxygen and 1 mole of propane. That is the mole conversions from the coefficients. And then we're going to go to 1 mole of propane, not from the coefficients, just always 1 mole in this part. We're going to go to the mass, which we said was 44.11 grams of propane. Now these are ifs. So if we use this much, then this is the amount that we use, not the amount that's left over. We end up with 8.36 grams C3H8. And again, this is how much we use. So it's really simple. We're going to get 10 grams of propane. That's how much we start off with. That's how much we have. Subtract out how much we use, which is 8.36 grams of propane. And then we're going to do the subtraction and then round it. 1.64, but this guy's only good to the 10th, so we're going to say 1.6 grams of propane is left over. That's it. That's how you do that part. Hope this helps. It's just one thing really fast. You can have different variations of them. And this part, we're going to moles. Well, we can do liters times molarity to get to moles. So realize that we don't have to do the same conversion to get the moles. We will always use a mole ratio to go from one chemical to the other, and that is stoichiometry. And hopefully you can make sense of my chicken scratch down here. The last equation is percent yield. This tells you how much you make compared to how much you could have made. The actual yield needs to be given, or you do it in a lab, not given. You do it in a lab, that kind of thing. So it's what's there actually sitting in front of you. A test question or a worksheet, it would say this much is produced. That means that's how much you actually have. And it's a yield, and therefore it is a product. In the theoretical, we get that going through the 4 boxes. So we calculate it going from the limiting reagent through the 4 boxes, and that will equal to the theoretical yield. Divide these out times 100, and you have percent yield.